Like I said, what interested me about foundations of quantum mechanics was that what seemed to be at stake there is the very viability of the scientific project itself, okay? I mean, let me put this maybe slightly more dramatically. And this is a way of saying, what does it mean to be interested in the foundations of physics? At least this is what it means for me. There are all kinds of scientific questions. How do rainbows work? How do galaxies work? How does cosmology work? Blah, blah, blah. Here's another scientific question, which I take it is the scientific question, and which is the one that was at stake in the foundations of quantum mechanics. Is the scientific project going to work out at all? Okay. The amazing thing about quantum mechanics, needless to say, there's a long history of philosophical critiques of something like naive metaphysical realism. Okay. There is, there's transcendental idealism, and there's everything under the, everything. There's a long history of philosophical critiques of the kind of naive metaphysical realism that you're usually taking for granted when you do science, okay, when you do physics. The interesting thing about quantum mechanics was that the critique was for the first time supposed to be coming out of the scientific project itself, rather than out of external reflection, philosophical reflection on the scientific project. The exciting thing about quantum mechanics in the lingo of horror movies was that the call was coming from inside the house.
Yeah,
okay.
Right.
And it was sort of the ultimate case of the call coming from inside the house. And this is what I take to be the scientific question, which at the end of the day is the really interesting one. Not what's going to be the correct scientific description of rainbows, or even what's going to be the correct scientific description of gravity, which is a much more profound question. But is the whole scientific project going to work out at all? Okay? Is it somehow going to run into a wall? Okay? Is it going to hit on something that it can't get past? Okay? This is exactly what Bohr thought had happened in the case of the measurement problem. And it's what people that I work with and admire over the course of my career have spent much of the career arguing did not happen. Okay? The scientific project as originally envisioned, according to these people, is alive and well. Okay? We got plenty of unsolved problems, but we do not have what Bohr thought we had, which is that the scientific project in some decisive way ran into a wall, okay, which it's not going to be able to get past. Okay? So for me, the great scientific question is the question of whether this project is going to work out at all. Okay? That's what I take to have been at stake in the measurement problem. You want to know why I was interested in the measurement problem? Because I saw that as being at stake. Because Bohr said that's what was at stake. If this helps solve the problem of quantum gravity, and it's not unlikely that it will help with that, because people are more and more convinced after having spent so many years unable to get to the bottom of quantum gravity that the only way to get through this is going to be to take very carefully apart what we mean by quantum mechanics in the first place, and so on. So it may be very important to solving that problem, but my interest in it has to do with its having an impact on an even bigger problem, and what I would think of as the scientific problem. Science, as I understand it, is the investigation of the question of whether the scientific project is going to pan out, okay, or whether it's going to get stopped someplace. Okay, we were told in the beginning of the 20th century that it had been stopped. Okay? And, like Mark Twain said, it turns out that the reports of its death had been greatly exaggerated. So if it helps out with quantum gravity, that's great. And I don't think it's implausible that it's going to help out with quantum gravity. It's certainly fooling around with very fundamental stuff in the immediate neighborhood of what we think we need to understand in order to solve quantum gravity. But I don't feel the need to justify my interest in it because of possibilities like that. It's coming to you right in the face. It's the question of, can the thing succeed at all? Okay? Are we ever going to be able to think of everything, tables and chairs and measuring instruments and ourselves, as encompassed within some fundamental unified scientific picture of the world? That's what interests me about all this.